Okay, now that we have finished up our discussion of heaps, we should talk about HeapSort, which is really kind of cool. And HeapSort is a method for sorting arrays. It does involve heaps. Let me give you the basic idea of it. First of all, why don't we start off with a heap? So I have a heap here. Maybe it looks like this. So there's a heap right there. And if I were to go ahead and make this into an array, because we're assuming it actually is an array. So I've got 100 there, 80, 60, 40, 17, 50, 32, 20, and a 3. Okay, so we've got this array over here, and what I'm going to do is I'm going to pop the array. So a 100 comes down, and then what happens is I take a 3 and I put it up there and I do a trickle down. So if I go ahead and I do that, we know that the 100 goes away, and then the 3 goes up to the top, and then it trickles down. So when it trickles down, the 3 comes over to here, and the 80 comes to here, and then with the 3 sitting over here, it swaps with the 40, and then the 3 swaps with the 20. So ultimately what is going to happen is that'll become an 80, that'll become a 40, that'll become a 20, and that becomes a 3. So that becomes an 80, a 40, a 20, and a 3. So now I have an array that looks like this. Okay, so there is an 80, 40, 60, 20, 17, 50, 32, and there is a 3. So I just 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here is my new heap here. And what I'm going to do is right down here at the bottom, I'm going to take this 100 and put it right there. Okay, and now what I'm going to do is I'm going to pop the heap. So an 80 is going to come off. I'm going to take the 3, I'm going to put it back up there, and I'm going to let it trickle down. So first of all, the 80 pops away. The 3 now goes up to the top. This 3 is going to hang out for a while, isn't it? And now I'm going to let it trickle down. And when I let it trickle down, the 3 is going to get swapped with the 60. So then the 3 would be here, and then the 3 would get swapped with the 50. So there's going to be a 60 here. There would be a 50, a 3, a 32. Okay, over here, there is a 40, there's a 20, and a 17. So I'm going to go ahead and draw this as an array. I'm going to redraw this array over here, but what's going to happen now is there's going to be a 60 here, there's going to be a 40, a 50, a 20, 17, 3, 32, okay? And then what's going to happen is way down here, there's going to be 100. And now what I'm going to do is back in, because remember, this is my heap right now. But there's still a space right over there. Okay, and what I'm going to do is I'm going to put an 80 in there. Okay, and I think you can see what's going on here. We keep popping off the next smallest element. The size of the heap gets smaller by 1, and then we reinsert that element down at the bottom. So what's going to happen over here, I'm going to pop this 60 off. Okay, what's going to happen is I'm going to bring the 32 up. So the 32 is going to go up to the top. And now I have to trickle this down. So what's going to happen is the 32 is going to swap with the 50. So I'm going to get a 50 over here. There's going to be a 32 and a 3. Over here there is going to be a 40. Over here there'll be a 20 and a 17. And if I were to go ahead and draw that, I'm going to get 50, 40, 32, 20, 17, and 3. Down here there's going to be a 100, and there's going to be an 80. And then I'm going to take the 60 and I'm going to reinsert it here. Okay? And I think you can follow this whole process through. Okay? So basically, if I have n elements, okay, we perform n minus 1 pops. Okay, and then insert after last element in current heap. Remember, each time I do a pop, this thing gets smaller by 1. So basically, we know that each one of these pops is at most log n. Okay, I'm doing it n minus 1 times. So that would just say the big O of n is n log n. Now, I just have one problem here. You may recall that I started this thing with a heap, but that's not always the case. I have some arbitrary array, and I'm going to make an arbitrary array up, I don't know, 23, 89, 5, 62, 53, 17, 1, 102. So there's some arbitrary thing. And I come over here, and if I draw this, I get 23, 89, 5, 62, 53, 17, 1, 102. And I go, well, wait a second. This isn't a heap. So before I can go ahead and do that algorithm that I just described to you before, I have to somehow make this into a heap. Well, there's a trick here, okay? And the trick goes something as follows. I want you to suppose that I have a heap over here. I'm going to make it a heap. 102, 53, 72. And here's another heap over here. 59, 3, and 42. And now I want you to imagine, okay, and I've got some number over here, question mark. Now the question, okay, so this is a heap on this side, this is a heap on this side. The question is what happens? It depends on the value of question mark whether this is a heap. Now if question mark is greater than 102 and question mark is greater than 59, I'm going to come over here and say, cool, it's a heap. But suppose that isn't true. Suppose 59 is smaller. Suppose I come over here and it's 39. Then what can I do to make this into a heap? Well, it's very simple. Just trickle down. And we've seen before that we can trickle down anywhere within the heap structure. So if I come over here and trickle down, I'm going to swap the 39 with the 102. So now this is 102, and this is 39. And now I have to come over here, and I would swap the 39 with the 72. And lo and behold, I have a heap. Okay, so how does that play over here? Well, here's the thing. If I take a look at this array right over here, and I go to the very last entry in the heap, 102, it's got no children. It's a heap. This thing's a heap. I come over here, this thing's a heap. I come over here, this thing's a heap. I come over here, this thing's a heap. So the nice thing is that when I have an array, approximately half of the nodes in this tree here have no children. They are already a heap. So what I need to do is just for half of them, I've got to come in and check, and if needed, trickle down. So for example, I come over here now and I go 62, and I go, alrighty, what I need to do here is trickle down. And if I trickle down here, I'm going to get a 102 up here and a 62 down here. So if I do that, 62, 102. Now I have to come over here and I have to trickle down here. And that says I'm going to swap the 5 with the 17. So I come over here. And I'm going to get the 5 here, and I'm going to get a 17 here. I come over here to 89. I've got to trickle down, and it says the 89 is going to swap with the 102, and it's going to stop right there. '89, 102, and then I have to come down here and I have to trickle this down. So the 102 is going to come up here, the 89 is going to come up here, the 62 is going to come up here. (102). This becomes 89. This becomes 62. And finally, the 23 that was up there comes down to here. Okay, so what does that mean? Well, this process here, what I'm going to call it is heapify. So HeapSort is first made up of this thing called heapify, and then those steps that I outlined for you before. Well, how long does heapify take? Well, for approximately half of the nodes, I have to do a trickle down, which is a log n operation. And we said to that, we have to do n minus 1 times something that is at most log n. So if I add these two together, that's approximately 3n over 2 log n. And again, what that just says to us is it says that big O of n is equal to n log n. And we're all done. End of HeapSort. I hope you enjoyed that.